Our next example is an initial value problem. Okay, so let's tackle this one right away. So we got 2y double prime plus y prime minus y equals x plus 1. And initial conditions, y is 0 equals 1, y prime is 0 equals 0. So characteristic equation, 2m squared plus m minus 1 equals 0, and that has roots negative 1 and 1/2 that any algebra student could find. So the solution of the homogeneous equation is c1 e to the negative x from this root and c2 e to the 1/2 x from this root. So the equation must have a coefficient of y double prime of 1 if we're going to use variation of parameters, so we're going to have to change our f of x into x plus 1 over 2. See, when we apply variation of parameters, this has to be 1. Go back to thinking about, we can always make the equation look like this, right? That's what I did. Divide both sides by 2. Okay. So that is going to be our f of x. So we need the coefficients. Here's our y1, here's our y1 prime, here's our y2, here's our y2 prime, and this is the first column replaced with 0 and x plus 1 over 2. And so now let's do a determinant. This times this is 0, and this times this is negative x plus 1 over 2 times e to the negative x over 2. Or sorry, e to the positive x over 2. And then this we get plus 1/2 plus 1 times e to the negative x over 2. Well, that's kind of nice. But when we simplify all this, the over 2's cancel, so we get negative x plus 1 over 3, and e to the negative x over 2 in the denominator is e to the positive x over 2 in the numerator, so we just get times e to the x. And so, integrating this, trust me on this one, it would work fine to integration by parts, and you get 1/3 times x e to the x. Okay. And if you struggle with integration by parts, check out my Calc 2 website and just look through integration by parts on that. So anyway, we also need u2 prime and then u2. So u2 prime, we just replace this column with our 0 and our x plus 1 over 2, and then find the determinant. This is e to the negative x times x plus 1 over 2 minus 0. So there's that part. And the denominator is going to be the same as before, so 3 has e to the negative x over 2. So putting all that together, we have x plus 1 over 3 times e to the negative x over 2. We got negative 1 here and a positive 1/2 when it comes upstairs. So that means we need to integrate this to find our u2. And so here's the third factored out, x plus 1 e to the negative x over 2. And trust me, integration by parts would be your technique of choice. And when you do that, you'll get negative 2 e to the negative 2x minus 2/3 x e to the negative 2x. And I know you're thinking I'm cheating because I use my software to do that, but you can use a TI-89, or you can say let u equal x plus 1 and dv equal negative x over 2, but that will work for you. Okay. All right, back to our problem. Our yp therefore is u1 y1 plus u2 y2. I have to go way back to here. What was our u1 again? It was this. And so that means here's u1 times y1, and here's our u2, which was rather complicated, times our y2. And now let's see what simplifies here. Well, e to the x times e to the negative x is just e to the 0, so negative 1/3 x. And we multiply this out, let's see what nice things happen. Maybe something nice does. Well, yeah, because e to the x over 2 times e to the negative x over 2 is e to the 0, so we just get negative 2. And then same story here, minus 2/3 x, so minus 2/3 x. So, and then these two things combined, they're like. So we just get negative x minus 2. So our solution, y equals yc plus yp, that's c1 e to the negative x plus c2 e to the 1/2 x minus 2. And now we use the initial condition y is 0 equals 1, y prime is 0 equals 0 to find our C1 and our C2. So since y is 0 equals 1, we have 1 equals C1 times e to the 0, which is 1, plus C2 times e to the 0, which is 1. So, and then minus 0 minus 2, so C1 plus C2 equals 3. Now y prime, we're going to have to find y prime to use that condition. So y prime is negative c e to the negative x, and then plus 1/2 c2 e to the x over 2. I said negative c, I should have said negative c1 e to the negative x, and then 1/2 c2 e to the negative x, and then minus 1 because the derivative of negative x is negative 1. So putting in y prime is 0 equals 0, we get 0 equals c1 plus half of c2 minus 1. So 2c2 plus negative 2c1 plus c2 equals 2. I added that to both sides and multiplied by 2 to get rid of the fractions. So we have this system of equations, c1 plus c2 equals 3, negative 2c1 plus c2 equals 2. So we got to solve that system, and when we do, which is a pretty easy one to find, you find that C1 is 1/3 and C2 equals 8/3. So the solution to the initial value problem is y equals 1/3 e to the negative x, since we got our C1, and plus 8/3 e to the 1/2 x, since we got our C2, and then minus x minus 2, the particular solution.
Please teach, give us another one.
Okay, next video.